Hey CW Apes, Mr. Kennedy here again with the next installment of Chapter 7 on climate change and oceans. This segment, we're really going to dig deep into a thing called El Nino, right? Or the Southern Oscillation, El Nino Southern Oscillation. So you might have heard of El Nino mentioned during different discussions of weather and climate and that sort of thing on the news. Sometimes a newscaster will say, hey, it's an El Nino year, so it's going to rain. I haven't really seen that, but sometimes, they say, hey, if it's an El Nino year, it's supposed to rain. At any rate, what is an El Nino year? Well, there are decades-long oscillations in ocean temperature and atmospheric temperatures that are predictable, one of which has been named El Nino. The ocean and the atmosphere kind of have regular patterns of flow or current that do tend to shift from time to time. So there's El Nino and El Nino's little brother, or I guess sister, La Nina, okay, which are examples of that very thing. Now, insofar as El Nino is concerned, it's really important that we also remember albedo effect and specific heat. So I'm going to show you this slide here on the black sand beaches of Hawaii and basically just ask you a pretty simple question. What has the lowest specific heat in this picture? White sand, black sand, water, soil? What do you think? So if you're stuck, let me put it this way. If you have a low specific heat, not only will you absorb heat energy quickly, but you'll lose it quickly too. Okay, so that's how you got to think about specific heat, right? So in this particular picture, probably the thing that we would probably be most interested in terms of specific heat, like the lowest specific heat, is probably going to be that black sand. It's going to absorb lots of heat energy really, really quickly, and at the end of the day, it's going to lose that heat energy really, really quickly as well. Water, on the other hand, it's going to slowly heat up over the course of the day and then slowly release its heat energy over the course of the night. So its specific heat is quite a bit higher. All right. Now, why is that important to us? Why do we care about heat being absorbed, being released, all that? Well, remember in our last lecture, we talked about the fact that latent heat energy in the water warms the air above it. That creates convection currents and, all that good stuff translates to weather. As the Earth spins, we get that whole Coriolis effect thing, and that creates all of these currents and air currents that go along with it. So across the ocean, we have water currents that are formed from the rising and falling of cold and warm seawater that are then spinning and in conjunction with the rotation of the Earth. And as that warm and cold seawater comes in contact with the air above it, then we also get weather. So it's all connected. So one of the other things I like to ask students is this question, okay? Why is it so nice in Santa Barbara? Okay, why is it so nice? Why does everybody want to go to the beach when it's hot in Fresno? Why does everybody want to go to the beach when it's cold in Fresno? Well, it really has to do with the difference in specific heat of land versus water. Another thing that's kind of interesting to think about, and I always ask my kids to think about this when they're at the ocean, how come certain times of day, if I'm standing there looking at the water, right, if I go look at the water in the morning, I don't want to give away the answer to the question just yet, but if I go stand and look at the water in the morning, the wind is always traveling in one direction, and then by the late afternoon, it's flipped and it's going the other direction. What's up with that? So if you look at this picture here, and you can see the circulating air over the water and land, it says during the day, the land heats up fast, which causes the air to be less dense, and the water heats up slower. So if I'm standing at the beach during the day, Mr. Kennedy's right here, okay, somewhere around, 9, 10 o'clock, the land's had ample time to, warm up. I'm going to be getting hit in the face with the wind, right? That's just how it works because the warm air, right, it's going to be rising behind me, and I'm going to get that cool air coming in off of the ocean. At night, it's going to flip-flop, okay? So the land cools off faster. That causes air to be more dense. Water has a higher specific heat, so the warm air's, traveling up high. So if I'm this little guy standing here with the plus, I'm gonna get hit in the back of the head, with the wind blowing there at night as the land cools off. So this is important in terms of affecting the weather of coastal communities. Another thing to think about is the rain shadow effect. A lot of coastal communities have mountains associated with them, and I don't know about you, but every time I go to Santa Cruz and things like that, the coastal range, the mountains there are gorgeous. You got ferns and lush vegetation all through those areas, and then you come over to our Sierra Nevada, and it's pretty, but it's hot and dry most of the time. There's a reason for that, and it has to do with this diagram here. As the air comes in off of the ocean, it tends to be warm and moist, right? And as it strikes the mountain ranges right there along the coast, the warm, moist air has to dump its load of water in order to get over the top. Where the wind hits the mountainside, we call that the windward side, and that tends to be green and lush and wet and much more attractive in terms of vegetation than, say, like the valley floor here in Fresno. Fresno, we live kind of on this leeward side of the coastal range. So once the air makes it over the mountains, it's very dry. The only hope we kind of have in terms of getting rain is that if some of that moisture made it over the top of the hill, and is still hanging on, maybe we can get some of that. Or maybe that the area around Fresno still has some water to evaporate up and, maybe help give us some rain. Otherwise, we're not going to get a whole lot of rain. Now, in conjunction with all this stuff that's moving, we also need to talk about currents in the ocean again. Okay, so the water in the ocean, different temperatures, warm water rises, cold water sinks, the earth is spinning, so you kind of have that Coriolis effect going on in the water. So basically, as the water comes up and then spins, the ocean forms currents where that spinning water collides with land masses. This creates circular movement of the water in the ocean, and those currents are predictable, and we do benefit from them in a lot of ways. There are a couple of things that are unfortunate occurrences that have happened as a result of those currents, and here's one of them. This is the Great Pacific Garbage Patch. If you're not able to see the map real well, this is Hawaii. The Great Pacific Garbage Patch lies just to the north of Hawaii. Right now, there is so much plastic in the ocean floating in the Great Pacific Garbage Patch that they say that even if we stopped putting plastic in the ocean today and somebody went out there and tried to pick up this garbage patch, we could never do it. The patch itself is the size of 3 of the countries of France. 3 Frances are out there, or maybe 2 of the states of Texas, because Texas is pretty big, right? And it's thick. It's 3 feet thick, and it's this goo, and the plastic breaks down into these tiny little particles called microplastics, and then they just travel throughout the ocean and are nearly impossible to filter out. So in California, we've passed laws and done things down here, here's us, to ban things like plastic bags in grocery stores and stuff, and that all sounds good, but we're right here. You can travel north to places like Washington and Oregon, and guess what? You can still get a plastic bag. You can go up here into Canada, you can go down here into Mexico, I guarantee you go over there to Japan and stuff like that, and you can still get a plastic bag. So some people argue, well, what are we doing? Why do we have a plastic bag ban if everybody else is still putting their garbage in the ocean? And to give you an idea about how much garbage gets in the ocean, literally there is a dump truck load, or basically a garbage truck load of trash that is dumped into our world's oceans, right? Somewhere on the surface of the earth every minute of every day, round the clock. Okay, that's a lot of trash being dumped in the ocean. And why communities do it? Well, we'll deal with that when we get to our garbage chapter. But for now, that's the Great Pacific Garbage Patch. It forms in a circular rotation of ocean currents called a gyre. And there are multiple gyres around the planet, which I'll show you as we get deeper into this. This is a picture of the Pacific Garbage Patch and some of the stuff you see in it. Okay. Now, these currents and all this other stuff that's floating around, it's really, really important in determining kind of like who lives where and what we find in the ocean. Okay, so we're going to spend some time just kind of talking about who lives where in the ocean. There are three major groups of ocean life. That which lives at the surface, which is basically our plankton, our phytoplankton, and zooplankton, all microscopic. These organisms outnumber all other organisms on the planet. And when we talk about saving life so that we can recycle carbon or pull carbon out of the atmosphere through photosynthesis, people always go, oh, don't cut down trees. Yeah, that's a good idea. And they always go to trees because you see trees and you can see the devastation that's left behind by their removal. But in reality, it's the phytoplankton that does the majority of the work. We need to save our oceans if we're really worried about that photosynthesis. All right, second group are the nekton group. All these organisms swim in the ocean freely, like fish and whales and squid and octopi, all that kind of good stuff. Then we get the benthos. These are the organisms that live on the bottom. So if we start polluting the ocean and all that, you can imagine, based on what I've given you here, who's going to be affected most and first. That Great Pacific Garbage Patch is pushing and just devastating that top 3 layers or 3 feet of the ocean, and that's where all that plankton lives. And plankton's kind of like, the foundation of the food chain. So it's really important that we take care of those oceans. Now, when this water moves across the planet and the water travels from warm areas to cold areas, we get oscillations or changes in temperatures. We're going to jump over to that and get into this thing called El Nino, or the Southern Oscillation, El Nino Southern Oscillation, put it all together. El Nino occurs when warm surface waters in the Pacific move back and forth between Indonesia and South America. I've got some great videos for you to watch so that you can kind of see what happens in this oscillation. During most years, the pool is held in the Western Pacific by steady equatorial trade winds. Okay, so basically, water is moving from South America towards Indonesia. During an El Nino year, it goes the opposite direction, and it messes everything up. Surface waters are driven westward by trade winds that allow the upwelling of cold nutrient waters, rich waters off of the west coast of South America, and it benefits all the fisheries. Every 3 to 5 years, the Indonesian low pressure system over there where, warm air is rising and all that, and same thing with the water, for whatever reason, surges back towards the east. Okay, during an El Nino year, the northern jet stream pulls moist air up from the Pacific. We get intense storms and heavy rains from California to the Midwestern states if the jet stream dips far enough. During an intervening La Nina year, we get hot, dry weather, and so much for our rain. The high sea surface temperatures can also cause some really, really awful hurricanes. So these oscillations of El Nino and La Nina, they are, basically oscillations that occur about every 7 years. There are other multi-decade oscillations that occur, like the Pacific Decadal Oscillation. It's a very large pool of warm water that moves back and forth across the northern Pacific about every 30 years. Has a massive impact on our salmon harvest in Alaska and the Pacific Northwest. The Northern Atlantic Oscillation, or NAO, is another oscillation that occurs between Canada and Europe. Okay, so all of these things are really, really important, and it affects who lives where. And then when I say who lives where, I'm not talking about people, I'm talking about fish, things like that. And as a result of fish, people follow economics and food. So that's where the who live where comes into play. Now, I got this graphic up here to kind of show you what's going on with El Nino and a normal year. So this is a normal year. During a normal year, the trade winds, as you can see here, blow across the surface and push air towards Indonesia. Indonesia is usually hot and warm, so that warm air rises to high altitudes, marches its way back towards South America, and falls. Ocean currents are kind of following suit, right? So the air is being pushed towards Indonesia, and that's dragging the warm water on the surface with it, bringing up cold water from underneath. That cold water creates what's called upwelling, and upwelling feeds the fish all along the coast of South America and makes for great anchovy fishing, right? So there's bumper crops, if you will, of anchovies, and people who make money hand over fist there. In terms of weather, it's usually warm and dry because that air coming down is warm and dry. So everybody's enjoying life in South America during the non-El Nino years. During an El Nino year, something weird happens. Like we get this surge that goes back the other way. And if you look close, right, that cold water upwelling stops. And that means no anchovies. So the fishery suffers, the businesses that rely on those anchovies suffer, and then check out what happens in terms of the weather, right? So you get this weird weather formation, and basically, instead of it being warm and dry here in South America, you could get monsoonal rains that lead to flooding and disease, right? And that's not good for anybody. So El Nino years are a big deal. They happen about once every 7 years. All right, so you're going to watch a couple videos on El Nino that are going to go into more depth than that. Just wanted to kind of touch on that with you here and bring our coverage of climate and oceans kind of to a close. Remember, these videos are always available from my YouTube channel, and the lecture PowerPoints can be found on my website. All right, see you next time.